Hi, hello. We're starting our fourth online lecture with Night Under the Stars. And just to remind you, we are streaming our lectures every Friday, 5 p.m. Central European time. I do encourage you to like and follow our Facebook page, Night Under the Stars OAUJ, so that you could get notification about amazing astronomy stuff and announcements about our events and lectures and much, much more. Please comment your questions. Please leave your questions in the comment section. I will answer all of them after the lecture. And so let's start. My name is Maria Bilinska. I am a PhD student in the Astronomical Observatory at the Jagiellonian University. And today I'm going to tell you about the galaxy clusters, which are the true islands of light of the darkness of the universe. Well, the thing is, our universe is a very dark place, not in archetypal meaning, like literature meaning, like in the Lord of the Rings or elsewhere, but from a particular physical point of view. Our universe is mostly dark, with some patches of light, and the galaxy clusters are one of such patches, very beautiful and very bright. So before we go to actually galaxy clusters, let us define what are the galaxies themselves. So as you know, we Earthlings reside inside of a galaxy, which is called a Milky Way. And you can see a part of our Milky Way if you go outside your home, or better to the countryside where there is no light pollution. And if the weather is clean, you can see this beautiful glimmering belt of stars, which is a part of our Milky Way, which is one of its spiral arms. Because if we manage to go outside of solar system and outside of our galaxy Milky Way, we would see something very that would look very much to the galaxy that you see right now on your screen. We live inside a spiral galaxy, and we live closer to the outskirts of it. So we have a very humble place inside of our home. It was just 100 years ago when astronomers realized that our own galaxy is not the only one that they see on the night sky. People used to think that some of the ghostly nebulae they saw in the sky were actually parts of the Milky Way. And it was just 100 years ago when the astronomers realized these are separate galaxies very far from our own, and they have billions of stars. So here on this slide, you can see one of the oldest photographs of the galaxies made at the brink of 19th and 20th century. And one of them is the Great Andromeda Nebula. And nowadays we know that it is no nebula, it is rather a galaxy. It is the closest giant spiral galaxy to our own. So now we say that nowadays we say that a galaxy is a huge collection of gas, dust, and billions of stars with their solar systems and planets and comets and asteroids all held together by gravity. This means that no wayward star or comet can escape a galaxy because it is held inside by gravitational field of all the other objects around. The galaxies come in all variety of forms, sizes, and even colors. So a galaxy may have spiral arms, just like Milky Way, or it may look like a pancake or a disc. It may resemble a soccer ball or a potato. It can be blue and red, and it can be very, very different in sizes. So here on the right panel, you can see a size chart for 4 giant galaxies. And exactly all 4 of them are considered to be giant. If our Milky Way, even our Milky Way galaxy, which rather looks like a tiny blue bug here, is actually a giant spiral. There are galaxies that are way, way smaller than Milky Way. IC 1101 galaxy, which you can see in the bottom of the right panel, is the largest observed so far galaxy. It is a real monster. And such monsters, they reside in the very heart of galaxy clusters. And right now we will talk how they form. So let us try and spy on a life of one single galaxy called NGC 4874. If we zoom out enough, this is the galaxy I'm talking about, and I hope you can see my cursor, you will see that it is surrounded by many, many more smaller galaxies, and that's the way it grows. It actually eats up smaller galaxies around it, and so it becomes bigger and bigger. When two or more galaxies merge, they form bigger galaxies. And the cluster you can see right now is a Coma cluster, one of the closest to Earth. It's situated on the distance of just around 340 million light years, so it's like nearby. It has a little bit more than 1,000 galaxies. It is very massive. Its mass is around quadrillion solar masses, so it weighs more than 1,000 times more than a Milky Way galaxy. So a galaxy cluster is a massive conglomerate of hundreds and even thousands of galaxies, all bound together by their mutual gravitational attraction. In this image, you can see one of the examples of the galaxy clusters. It's another one, and you can again see several merging galaxies. For example, and again, I hope you see my cursor, these two are merging to become one, and these two galaxies are interacting. And just like galaxies, galaxy clusters also can merge to form even bigger clusters, and we will talk about this right away. So a typical galaxy cluster has between 50 to several thousand galaxies. It stretches across a distance of around 30 million light years, and it is a very, very massive object. It is 1,000 times heavier than the Milky Way. And it doesn't really seem like if there are anything else inside the galaxy cluster. We know that there are galaxies there. We know that it is a community of galaxies. But when people come to our lectures, they often ask us, is that it? Is galaxy cluster, does it consist of only galaxies? And that's a very good question. Because to answer it, we need to look at the galaxy cluster from many different perspectives. Well, the image that you can see now is an image of Pandora cluster in visible light. What does it mean, invisible light? Isn't all the light visible? But actually, no. The visible light is the emission, the electromagnetic waves that we are able to see with our own eyes or with the use of optical telescopes. So in this image of Pandora cluster, this particular way of seeing the Pandora cluster would be possible for any human if we could have telescopic vision, if we could see like telescopes do. But as I said, what we can see is a very, very narrow band of emission that is possible there in nature. As you know, light is at the same time a wave and a particle. But right now, we're more interested in its wave nature. As any wave, the electromagnetic wave has a wavelength, and it can have a variety of wavelengths. So from very short ones, like here, to very long ones, the wavelength, I should say, is the distance between the two peaks. So here, we're talking about a larger wavelength, and here we're talking about even larger wavelength. And if we go to the left, to gamma rays, we will be talking about small wavelength. All the possible wavelengths of electromagnetic waves, is called spectrum of electromagnetic waves. And all the spectrum is divided into several wave bands. Visible light is the realm of humans. We can see only invisible light, unfortunately, and that's all. But if we go to larger wavelengths, there is a variety of wave bands. There is infrared here, and microwave and radio. If we go to shorter wavelengths, there is ultraviolet and X-ray and gamma ray. And all those, I hope, except of gamma ray and perhaps X-ray, you meet in your life very, very often. So all of these kinds of electromagnetic waves reach Earth from different objects in space, from galaxies and galaxy clusters. So let's take a look at Pandora cluster once again. This is a photograph of Pandora cluster in visible light. We can see individual clusters here. They look like red dots here. We can also see several stars, but they belong to our own galaxy, so don't mind them. If we go to X-ray photograph, we would see something different. So if in visible light we can see individual galaxies, in the X-ray, Pandora cluster looks rather like a blob of X-ray emission. It looks so different because basically most of the X-ray emission is coming not from the galaxies, it is coming from the hot gas that is filling the galaxy cluster. So when we're talking about galaxy cluster, we should be rather talking about a blob of hot gas in which the galaxies are floating. So it looks like a soup a little bit. And the gas is really, really hot. It's around tens of millions of Kelvin. It is very hot, but it is not dense. It's rather sparse. So visible light and X-ray give us understanding of different physical processes that are going on inside the galaxy cluster. And if we go to radio, the picture will be even more different. So Pandora cluster, it's really a mystery, you may say. You see it one way in the visible light, another way in X-ray, and in radio you just don't recognize it. Yeah, because you're looking at multi-wavelength. We want multi-wavelength imaging because it gives us a broader vision of what kind of physics is going on inside the galaxy cluster. So the visible light gives us imaging of the individual galaxies inside the galaxy clusters. The X-ray light gives us understanding that there is a hot gas inside the galaxy cluster, and we can see it, and that's not everything. If you look carefully at an image of Pandora cluster in X-ray, you will see that it's actually not one blob of emission. There are actually two blobs of emission. So this one, there's one, and there's the second one. And it's again not an artifact. This cluster actually consists of two components, which once were separate galaxy clusters that are merging right now to form one solid Pandora cluster. So some clusters merge together to form a bigger cluster. And when we go to other wave bands, for example, to radio, we have even more proofs that there is actually merger happening. So this beautiful elongated red structure, well, it is red in false colors. I didn't say that, but you should understand that we cannot see X-ray and radio. So we have to depict them in the false colors. So this beautiful elongated structure is actually a front of a shock wave which formed because the two clusters merged. So when one cluster and another one merge, a wave appears that spreads in two waves appear that spreads in opposite direction outside the galaxy clusters. And sometimes in some merging clusters, we can see those beautiful, huge, elongated things. They're very nice. And well, you can tell me, okay, if multi-wavelength is so important, Why do astronomers want to make so many photographs in visible light? Why do we want Hubble? Why don't we go multi-wavelength everywhere? And well, the fact is, even visible light can give us a lot information, even not going multi-wavelength. I really suppose that in this photo you have already noticed something very interesting. So we're looking at a galaxy cluster here, and we see cluster members of this MAGS galaxy cluster. The cluster members are galaxies that are members of galaxy cluster. So this galaxy and that one and that one and that one, all that look normal, are the members of the galaxy cluster. But there are also several thread-like features. They look very bright and shiny, and it's not clear what they are. And some of them may resemble you very distorted images of the galaxies. And if you thought about that, you actually were right. Because what you see here are very distorted images of the galaxies that lie well behind MAGS galaxy cluster. They are not cluster members of this cluster, but they lie way behind. Why do we see them? We see them because of gravitational lensing. So if we have a very massive object, say a galaxy cluster, and you remember that it may be as massive as quadrillion solar masses, if we have a massive object and an observer who can observe this massive object, and if we have the third object behind it, so a galaxy, the light that is coming from a galaxy is being bent nearby the galaxy cluster. So it's not going straight, it does not follow straight lines, but nearby the galaxy cluster, the very massive object, it is being bent. And so some of the light reaches Earth. And so we may sometimes see those beautiful thread-like structures, which are distorted images of very, very distant galaxies. And it's a very nice thing because, as you know, if an object is situated very far away, it does not mean that it is simply far away. When we're observing it, it doesn't only mean that we're simply observing a very distant object. It also means that we're looking back in past. Okay, say we have an observer on Earth, say we have an astronomer who is observing a galaxy that is situated million light years away. Million light years away means that the light from this galaxy needs million years to travel to Earth. So when the light comes to Earth, we see the galaxy million light years away. So we're kind of looking back into the past. It's like a window to the past of the universe. So I can say that when we study galaxy clusters, we also may study the history of the universe. Well, here on this slide, you can see a timeline, the timeline of our world. Here it began, so this is time 0. Here the Big Bang occurred, and here we are. That's where we reside. We reside in 13,700 million year old universe. This is the way we can see galaxy clusters nearby or relatively nearby. Okay, Coma cluster is situated around 340 million light years from us. Yeah, I think I said it right. But anyway, it is considered to be a close cluster. However, astronomers also observe very different clusters. And that one, the picture to the left in the bottom of the slide, is one of the most distant galaxy clusters that have been observed so far. Not all the galaxies, not all the objects that you can see here belong to this cluster, of course. Only the red galaxies that you can see as red dots, they are the cluster members of this very different galaxy cluster. And the light we see leaving this cluster is situated right here. So the light that comes to Earth from this galaxy cluster went out from galaxy cluster around 13,000 million years ago. So it's very, very far. And well, okay, since we have that distant galaxy cluster, it has galaxies, of course, and it has stars that have been born even earlier. So when have they been born? And well, the scientists that were studying and observing this galaxy cluster, Willis's group, they showed that these are the most early stars, or at least one of the most early stars that formed there in the universe. So they were born at the brink of the dark ages and the first galaxies. So they were born around 317 million years after the Big Bang. Before that, there was no light in the universe, as we know. They were dark ages. So it's really interesting and very impressive, not just to study galaxy clusters, but also very distant ones. And well, unfortunately, we do not have enough sophisticated vision because of our biology to simply look at the sky and see galaxy clusters. For our view, they're just simply too far. So I can't tell you go out to the countryside where there is no light pollution, when the night is dark, and if you look east, you will see a beautiful galaxy cluster. I can't do that. But anyway, I do encourage you to observe the night sky because it is very beautiful. And I have several more minutes of my talk, and I'd like to spend it by telling you about one of the most, I don't know how to say, splendid astronomy events of July. There are much, much more than those three, actually. And I also do encourage you to Google them, but I want to tell you about three of them. So first of all, noctilucent clouds. Why do you want to see them? The other name of noctilucent clouds are night shining clouds. These are the highest clouds that are formed in the Earth's atmosphere. Higher than that, there are no clouds there. So they are formed between 75 to 85 kilometers above the Earth's surface. And they are seen not in daylight, but they are seen right before the dawn or shortly after the sunset. They are really shining. They look like silver ghosts on the night sky. So I can assure you that when you see the noctilucent clouds first, you're going to be looking for them every night afterwards, every evening. So noctilucent clouds are observable for the whole summer, and I do encourage you to try and see them. The second object is, of course, you have heard about it, is comet C2020 F3 Neowise, and it is visible right now. Well, not right now because it's cloudy and not late enough, but it is observable in these days. So it is called the Great Comet also. It is the second brightest comet the first brightest comet for the last 23 years. So you surely should see this one. And though I do not have such beautiful photographs of such comet, but I've spent some time to observe it, and well, I never regretted that time. The third event that I would encourage you to look for the night sky are Delta Euclid's meteor shower. It is peaking between 28th to 29th of July, and there will be around 10 to 12 meteors per hour. This meteor shower is not that abundant as Perseids meteor shower in August, which you also should try and observe, but also a very nice one. So now I'm going to finish my lecture and I'm going to take questions. Thank you. Okay, no questions. If any questions, just post something and I'm gonna answer. Okay, guys, so this video is going to be on our webpage. To get notifications about our lectures and some cool astronomy stuff, please like and follow our page. You'll find a lot of interesting things there. And thank you for today. Thank you for your listening. If you have any questions later, just please post them and I'm going to answer. Thank you very much.